One, two. Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also on the Melbourne television repeater VK3RTV, digital channel 1, and on my two streams, Discord. Go to, if you haven't got Discord, install Discord, or at least register on Discord, and then go to my qrz.com page, VK3CSJ or VK3EKH, and I provide a universal link of sorts that allows you to go to the astronomy chat room on Discord, which is where the HD stream for the video is also streaming, and also on my YouTube channel, VK3CSJ. Just type in VK3CSJ and look for the live indicator, and hopefully it'll work okay. We're streaming on those streams right now, on those formats, on those platforms, whatever you want to call it. And we're here on this 10th of October. Now I'm monitoring myself on the 9000D, and I think the audio is okay. There's so many variables in this place, it's just unbelievable. Where's the volume? 1, 2, no, not that one. 1, 2, 3, 4, 5. It sounds just a bit too much. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sorry about this, ladies and gentlemen. But I'm only just trying to get things together here, and I've got so much crap on this bench, it's unbelievable. 1, 2, 3, 4, 5. 1, 2, 4. 1, 2, 3, 4. Right. Okay, I think that'll do. I might just knock that down a bit. 1, 2, 3, 4, so YouTube doesn't complain. And probably bring that one up again. 1, 2, 3, 4. 1, 2, 3, 4. Okay, we'll see how we go with that. All right, I've just spent the last 20 minutes putting things together, and I've found a swag of interesting articles on the website called The Conversation, and at varying degrees of length, but I'll try and work my way through them. Problem I've got though, and this is what I've been struggling with, a lot of the images on the Conversation website have a different attachment to them. They're not all JPEG images, and I can't save the file easily, or at least I can't bring it across to vMix, because vMix doesn't understand what the file format is. One of those things. To give you an idea what I'm talking about, let me see if I can grab an image for a second. This one, I was actually able to save that. It's funny how some pictures I were able to save, but others I couldn't. And some I can save a link, and that worked. But others, oh my God, what have I done? But I'm screwing it up for myself here. Can I go back on that? I don't know if I can. What was it now? What was the article? I screwed that up. Oh, what was it? Remember, I think it was... hang on a sec, ladies and gentlemen, while I'm still fiddling here. The Conversation is an interesting website. It's got science and tech, which is the one that I'm interested in. And let me just see where I was. There's that one there, there's that one there, that one there. So that must have been the one dealing with what Trump wants to do. Good old Trump baby. All right, yeah, I think that's it. Yeah, that's it. All right. Anyway, suffice to say that some of these articles, some of these images, are in an AVIF format, I think it was. There. This one here particularly, save image as. Yeah, AVIF. I was right. Yes, I thought it was. Mumble. Anyway, its attachment is an AVIF format, AVIF, and where I can save the image to the file on the computer, unfortunately vMix doesn't seem to accept AVIF, and I've been fiddling with that, and I've been wasting time on fiddling with it, so just have to live with that for tonight. Anyway, having said all that gunge, welcome to tonight, ladies and gentlemen. There's probably no one listening, so that's fine. We're broadcasting, like I say, on 80 metres and on Melbourne TV and on my 2 streams. So that's it in a nutshell. This broadcast is on behalf of the Astronomical Society of Victoria, which is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our 2 metropolitan locations, the Morley Community Village and the Melbourne Observatory. We host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during the Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes astronomy to Melbourne's parks and schools. Please check the calendar on the ASV website for details if you are interested in attending one of these events. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope, and also currently working on the installation of a series of remote telescopes at the Dark Sky site. And once complete, which they basically are, they'll become accessible to members with a special training involved and registering. Thanks to the generous donation of a late member, Leon Mao, the Leon Mao Dark Sky site, which he donated to the ASV many years ago, is located north of Melbourne, just north of Heathcote. It has a pristine night sky, a pristine night sky for deep sky observing. There's a 25-inch telescope there. There's also a 40-inch telescope and a accessible wheelchair telescope, or I should say a 16-inch telescope, which is accessible for folks that are in wheelchairs. Special mount is designed for that one. There's also a fully steerable 8.5 metre radio telescope up there, a 30-foot Kennedy dish, and that's fully steerable now, and can be accessed with involvement with the radio astronomy section. Good evening to any RAS members that may be listening to tonight. And there's also an annual yearbook published by the ASV, and it is made available to members. And I've got a copy of the yearbook, the 2024 yearbook, but that's basically what the yearbook looks like. A reasonable little publication, which is ideal for astronomers, for information in general. And also the Crux newsletter, which is a bi-monthly newsletter. No, that's CQ TV, not that one. Struth Crux, there we are. So that's our glossy magazine that gets produced on a bi-monthly basis for members, full of information. And of course the ASV has its logo, which is this guy. There we go, just the camera focus there for a sec. Focus, yep, there we go. And of course you've got the Southern Cross and the pointers. And there is a Latin motto with that, which once translated stars for is this way to the stars. The ASV is governed by a set of rules which should be read before applying for membership. There's a link to the ASV rules on the About Us tab on the homepage website. Straight under that is a list of past ASV presidents, just for your information, starting off from the year 1922 right up to the current president of 2025 since 2022, Mark Ascario. But it has a list there of all the presidents of ASV since 1922, just underneath all that I've just read out about the ASV in general. The ASV website is www.asv.org.au, asv.org.au, and all will be revealed. Just looking at the revolving banner here, there's a few things that are coming up next year that they're advertising, so I might suggest that just go to the ASV website to look at all those revolving banners to indicate what is coming up in the near future. Alright, you're tuned to ASV Radio, VK3EKH. I'm just going to pick up a little bit from Tanya Hill at the planetarium. What she call it again? Sky Notes, that's it. So as of tomorrow, what's the date today? It's the 10th, so 11th, yep. So sunrise tomorrow morning will be at 6:40 a.m. 6:40 a.m. to setting at 7:33, with the day being 12 hours and 52 minutes long. 12 hours and 52 minutes long. On Monday, the 21st of October, sunrise will be at 6:26 a.m, setting at 7:43, with the day being 13 hours 16 minutes long. And by the end of the month, on Halloween, Friday the 31st, I don't know why I mentioned Halloween, but anyway, you go into, is it? Oh, I won't go there. So sunrise is at 6:14 a.m. and setting at 7:53 p.m. with the day being 13 hours and 39 minutes long. So our days are progressively getting longer. Hope you managed to adjust to daylight saving this week. I must admit it's been a bit of a trick. And I've got about half a dozen clocks. Fortunately, the clock in front of me is correct, but and the computer clock's okay. But I've got half a dozen clocks I haven't fixed up yet. So anyway, that's another story. There was a full moon on Monday the 7th. Everybody bragged about that as being a super moon. It was a little close. The moon was a little bit closer to the Earth, only by a small percentage. And I must admit, looking through the window, the moon certainly looked bright and round. So if I had had the observatory up and running, it would have probably produced some excellent images, actually. But anyway, it was a full moon. There's a third quarter on the 14th, and a new moon on the 21st, and a first quarter on the 30th of the month. Mercury, after its solar conjunction, is now visible again in the west from 8 p.m. before setting around 9 p.m. So, like I say, like I've said many times in the past, if you haven't seen the planet Mercury by eye, you think that because Mercury is the closest planet to the Sun, you can't see it, but you can. There are times where the orbit of Mercury places it in conjunction with Earth's orbit, in a position where you can see Mercury above the horizon after sunset, or conversely in the morning before sunrise, but you can see it, and there it is. So Mercury, after its solar conjunction, it is now visible again in the west from 8 p.m. before setting around 9 p.m. Venus is drawn too close to the Sun this month for observers in Melbourne. Mars is about to have its solar conjunction and pass behind the Sun, but can still be seen this month low in the west at twilight from around 8:15 p.m. before setting by 9:30. Jupiter is now visible again after 3 a.m. in the east before fading in the dawn light by 6:30 a.m. Saturn can now be seen again in the east at dusk from 8 p.m. which it will move across the northern sky before setting in the west by 5 a.m. And I think the current rings of Saturn, they're kind of a slide on to us. I think they're slightly angled, but they're, at the moment, the rings are slide on. I think meteors. The Orionids appear from the 15th to the 29th, but peak on the 21st, 22nd, which perhaps with perhaps 30 meteors per hour from midnight until dawn, centered on the constellation Orion near the red supergiant star Betelgeuse. They are typically very fast and bright, entering the atmosphere at 66 kilometers per second and vaporizing 100 kilometers above the surface, leaving persistent trails. Yep. So the peak of the Ionids is around the 21st to the 22nd. Okay, I said that. What else do they say here? The orange shower was first recorded by the Chinese in the year 288 AD and is associated with Comet Halley. In 1705, Edmund Halley, after studying records of comets that seemed to reoccur, using Isaac Newton's new laws of motion, calculated the comet's orbit and predicted its return in 1758, which is something he did not live to see. Every 75 years, Comet Halley passes through the inner solar system, leaving a trail of particles for Earth to pass through twice a year. During April, May is the Eta Aquarids, and then the October Ionids. All right, won't worry about all that. Won't worry about that. And I did all that last week. So, okay, that's just a quick glance at the Sky Notes. Okay. What is it? 10:18. Now, this is an article from the Conversation website, courtesy of theconversation.com, under the Science and Tech tab. And this one's called Mysterious Molecule Found on Brown Dwarf Casts Further Doubt on Potential Signs of Life on Venus. And this was published the 3rd of October. Let me have a quick scan of that. Yeah, there's no actual images associated with this article, so that was fine. Only discovered in 1990s, these in-between cosmic objects aren't big enough to burn as hot and bright as a true star, instead usually giving off a warm, dim glow, is how that article starts. In new research published today in Science, a team of astronomers report the detection of a surprising substance in a brown dwarf known as Wolf 1130c, a chemical called phosphine, which has been in focus of controversial claims for evidence of life on Venus. However, the presence of phosphine in the turbulent and inhospitable atmosphere of a brown dwarf shows our understanding of the life cycle of this small, simple molecule is incomplete, and casts doubt on the idea can be regarded as a biosignature of alien life. What are brown dwarfs, you might ask? Like true stars, brown dwarfs are formed from collapsing clouds of gas in space. The gas heats up as it falls inward, but in a brown dwarf it never gets hot enough to trigger the fusion of hydrogen into helium, which powers stars. But as long as the cloud of gas is at least 13 times as heavy as Jupiter, it will get hot enough to fuse a slightly heavier kind of hydrogen called deuterium. This fusion will burn out quite quickly in astrophysical terms, after between 1 and 100 million years. However, the gravitational collapse and fusion create an enormous amount of heat in the brown dwarf's core. This creates convection loop. Gas near the core warms up and rises, transferring heat to the upper levels before cooling and falling back down. Brown dwarfs are much cooler than stars. The surface of the youngest and largest can reach up to 2000 degrees C, but the coolest are close to room temperature. Once the heat from the core reaches the surface layers of the brown dwarf, it radiates out in space, mainly in the form of photons of infrared light. Infrared wavelengths are difficult to observe with ground-based telescopes, but space telescopes such as the James Webb Space Telescope have a better view, and this gives us a better look at brown dwarfs. So what's going on with phosphine then, you might ask? Interesting chemical reactions and processes happen in brown dwarfs in ways they don't in hot stars. For nearby brown dwarfs, the James Webb Space Telescope can observe the outcomes of these chemical processes. It does this by looking for the barcodes of each molecule's specific patterns of dark lines in the spectrum of light emitted by brown dwarfs. Phosphine is a simple molecule with one phosphorus atom and 3 hydrogen atoms. In 2020, some scientists thought they detected a special signature in the atmosphere of Venus. The conditions on Venus mean that phosphine should be destroyed pretty quickly there, so detecting it would mean something was making a lot of phosphine. On Earth, phosphine is only present due to life, and so phosphine has been explored extensively as potential sign of life. So the potential detection on Venus is exciting stuff. But dig beneath the headlines and it is more subtle. Phosphine is found in the atmospheres of Jupiter and Saturn, and no one is proposing life exists in the clouds of these planets. The reason is we understand how phosphine can be created and survive in lower levels of the atmosphere on these planets. Then it rises to the surface where it is rapidly destroyed, but not before we see its special signature. So what about phosphine in brown dwarfs then? What happens to phosphine in hotter and bigger systems such as brown dwarfs and hot Jupiter exoplanets? According to some models, we should see significant amount of phosphine here, but earlier JWST observations looking at 23 brown dwarfs with temperatures between 100 degrees C and 700 degrees C found no phosphine. Yet the recent observation of phosphine on brown dwarf Wolf 1130c, temperatures at approximately 320 degrees C, matches the models very well. But why? The researchers behind the new study aren't sure yet. The best guess is that it might have something to do with the fact that WRF 1130c is old and contains low concentrations of metals. At this stage, they conclude with a simple statement: there is no consistent model that explains the amounts of phosphine we see on Jupiter, Saturn, and WRF 1130c, other brown dwarfs and exoplanet gas giant atmospheres. Without a better understanding, the use of phosphine as a biosignature is questionable. So perhaps there was phosphine on Venus after all, but the cause was unknown. Chemistry or physics, not biology. Alien life remains the hypothesis of the last resort. So, that's courtesy of The Conversation. Interesting website. You're tuned to ASV Radio, VK3EKH. I don't think I'll read all this article out, or I might, because it's mostly pictures. I've got one picture I managed to save out of this one, so I'll bring that up. There it is. What this article is, courtesy again of The Conversation, a US startup plans to deliver sunlight on demand after dark. Sounds like a good idea, doesn't it? Can it work? And would we want to? A proposed constellation of satellites has astronomers very worried. Unlike satellites that reflect sunlight and produce light pollution as an unfortunate byproduct, the ones by US startup Reflect Orbital would produce light pollution by design. The company promises to produce sunlight on demand, with mirrors that beam sunlight down to Earth so solar farms can operate after sunset. What a wonderful concept. It plans to start with an 18-metre test satellite named Earendel 1, which the company has applied to launch in 2026. It would eventually be followed by about 4,000 satellites in orbit by 2030, according to the latest reports. So how bad would the light pollution be? And perhaps more importantly, can Reflect Orbital satellites even work as advertised? In the same way you can bounce sunlight off a watch face, for example, to produce a spot of light, Reflect Orbital satellites would use mirrors to beam light onto a patch of Earth. But the scale involved is vastly different. Reflect Orbital satellites would orbit around 625 kilometres above the ground and would eventually have mirrors 54 metres across. When you bounce light off your watch onto a nearby wall, the spot of light can be very bright. But if you bounce it onto a distant wall, the spot becomes larger and dimmer. This is because the sun is not a point of light, but spans half a degree in angle in the sky. This means that at large distances, a beam of sunlight reflected off a flat mirror spreads out with an angle of half a degree. What does this mean in practice? Well, let's take a satellite reflecting sunlight over a distance of roughly 800 kilometers, because a 625 kilometer high satellite won't always be directly overhead. But beaming the sunlight at an angle, the illuminated patch on the ground would be at least 7 kilometers across. Even a curved mirror or a lens can't focus the sunlight into a tighter spot due to the distance and the half-degree angle of the sun in the sky. Would this reflected sunlight be bright or dim? Well, for a single 54-meter satellite, it will be 15,000 times fainter than the midday sun, but this is still far brighter than the full moon. Last year, Reflect Orbital's founder, Ben Noack, posted a short video which summarized a test with the last thing to build before moving into space. It was a reflector carried on a hot air balloon. In the test, a flat square mirror roughly 2.5 meters across directs a beam of light down to solar panels and sensors. In one instance, the team measures 516 watts of light per square meter, while the balloon is at a distance of 242 meters. For comparison, the midday sun produces roughly 1000 watts per square meter, so 516 watts per square meter is about half of that, which is enough to be useful. However, let's scale the balloon test to space. As we noted earlier, if the satellites were 800 kilometers from the area of interest, the reflector would need to be 6.5 kilometers by 6.5 kilometers, 42 square kilometers. It's not practical to build such a giant reflector, so the balloon test has some limitations. Reflect Orbital's plan is simple satellites in the right constellation shining on existing solar farms, and the goal is only 200 watts per square meter, 20% of the midday sun. Can smaller satellites deliver? If a single 54-meter satellite is 15,000 times fainter than the midday sun, you would need 3,000 of them to achieve 20% of the midday sun. That's a lot of satellites to illuminate one region. Another issue, satellites at 625 kilometers altitude move at 7.5 kilometers per second. So the satellite will be within 1,000 kilometers of a given location for no more than 3.5 minutes. This means 3,000 satellites would give you a few minutes of illumination. To provide even an hour, you'd need thousands more. Reflect Orbital isn't lacking ambition. In one interview, Noack suggested 250,000 satellites in 600-kilometer high orbits. That's more than all the currently catalogued satellites and large pieces of space junk put together. And yet, the vast constellation would deliver only 20% of the midday sun to no more than 80 locations at once. Based on our calculations above, in practice, even a few locations would be illuminated due to cloudy weather. Additionally, given their altitude, the satellites could only deliver illumination to most locations near dusk and dawn, when the mirrors in low Earth orbit would be bathed in sunlight. Aware of this, Reflect Orbital plan for the constellations to encircle Earth above the day-night line in the sun's synchronous orbits to keep them continuously in sunlight. So, are mirrored satellites practical means to produce affordable solar power at night? Probably not. Could they produce devastating light pollution? Absolutely. In the early evening, it doesn't take long to spot satellites and space junk, and they're not deliberately designed to be bright. With Reflected Orbital's plan, with reflect orbitals planned, even if just the test satellite works as planned, it will sometimes appear far brighter than the full moon. A constellation of such mirrors would be devastating to astronomy and dangerous to astronomers. To anyone looking through a telescope, the surface of each mirror could be almost as bright as the surface of the sun, risking permanent eye damage. The light pollution will hinder everyone's ability to see the cosmos, and light pollution is known to impact the daily rhythms of animals as well. Although reflect orbital's aims is to illuminate specific locations, the satellite's beams would also swoop across the Earth when moving from one location to the next. The night sky would be lit up with flashes of light brighter than the moon. The company did not reply to the conversation about the concerns within the deadline. However, it told Bloomberg this week it plans to redirect sunlight in ways that are brief, predictable and targeted, avoiding observatories and sharing the locations of the satellites so no scientists can plan their work. So scientists can plan their work. The consequences would be dire. It remains to be seen whether Reflect Orbital's project will get off the ground. The company may launch a test satellite, but it's a long way from that to getting to 250,000 enormous mirrors constantly circling Earth to keep some solar farms ticking over for a few extra hours a day. Still, it's a project to watch. The consequences of success for astronomers and anyone else who likes the night's dark sky would be dire. That's a pipe dream. I don't think that'll ever get off the ground, literally. You're tuned to ASV Radio VK3 EKH, and let me just go back to the picture, to the camera. All right. Well, that was an interesting article, I guess. Let's hope that never takes place. There's other ways of generating power. Now, this is an interesting one too, courtesy of the conversation, but I think I might have been able to save one image here, and it's a really interesting image. Okay. This goes back. This was published on the 20th of August 2025 at 10:56 a.m. This article is titled "The Most Powerful Tool in an Astronomer's Arsenal is a Lens, but not the kind you might think of." Astronomers are living in a golden age of bigger and better telescopes. Oh yeah. But even our most advanced technology pales in comparison to the power of nature's own cosmic magnifying glass, strong gravitational lenses. In less than 50 years, we have gone from the first ever discovery of a strong gravitational lens to now finding thousands. As new telescopes come online, we are expecting to discover thousands more. With these lenses, we can look deep into the universe and catch glimpses into the most puzzling of contemporary cosmic mysteries, dark matter and dark energy. So, what are gravitational lenses and how do they work? Gravitational lenses are the most visually spectacular demonstration of Albert Einstein's theories of gravity. According to Einstein, mass bends and warps the very fabric of space in much the same way that a heavy bowling ball placed on a mattress will bend the mattresses beneath it. Everything with mass, you, me, a leaf, an atom, bends space-time in this way. But it's only when an object is really massive, such as the entire galaxies and clusters of galaxies, that this effect becomes so apparent. As light travels from distant objects and passes these massive galaxies, the warped space-time around them bend and focuses this light, magnifying it for us to see. And there's a little graphic here, and I think I managed to save this graphic. Yep, there it is. In this diagram, In this diagram, it actually says that. In this diagram, a cluster of many galaxies distorts the light rays from another galaxy behind it. When viewed from Earth, we see the background galaxy as a warped and highly magnified arc around the foreground cluster. And the diagram kind of illustrates that. Continuing, we're not always in the right place to see this effect. Just like how you'd need align a magnifying glass in front of your eye, we only observe the gravitational lensing effect when there is a chance alignment of the background object and the foreground lens and us. On the rare occasions when this happens through our telescopes, we see multiple distorted but magnified versions of an object that we wouldn't otherwise be able to see because it's too faint. I've got another image here. This one here. Alright. So in this image you're seeing here, the Hubble Space Telescope captures a striking gravitational lens called GAL-CLUS-022058S. Here, a cluster of galaxies is warping a background galaxy, giving us a close-up view of how these galaxies looked 9 billion years ago. That's what we're looking at. Even Einstein couldn't have predicted how important gravitational lenses would become to modern astronomy. In fact, he believed them impossible to observe at all. This was because Einstein was thinking about gravitational lensing around individual stars, not galaxies. It wasn't until decades later that the astronomers came to realize just how massive galaxies are and just how full of them our universe is. Impressively, gravitational lenses can also reveal details about things we can't see at all. Theories predict about 85% of the matter that make up the universe is invisible, stuff called dark matter. The way a gravitational lens bends and warps light allows us to measure how much matter is in galaxies. Not just the regular matter we can see, but the dark matter as well. Gravitational lenses can also help us map galaxy clusters across the universe, helping us to understand its shape. Is our universe perfectly flat like a sheet of paper? Or does it have curvature so it is like a sphere, or a flare outwards like a horse saddle? That depends on how dense the universe is, and mapping galaxy clusters helps us measure the density of a hypothetical force known as dark energy. Gravitational lenses typically make the background objects 10 to 100 times brighter than they would otherwise be, and this effect provides high-definition view of the distant universe. The James Webb Space Telescope has been taking advantage of this magnification boost to get a glimpse into what the universe was like in its infancy more than 13 billion years ago, shortly 300 million years after the Big Bang. Looking far into the past helps us piece together how our own celestial home, the Milky Way galaxy, formed and how it might change in the future. The catch to all this, gravitational lenses are rare, akin to a needle in a cosmic haystack. To find them, we need high-quality images of large swaths of the night sky. This year, 2 new sky-watching projects are expected to revolutionize the field. The European Space Agency's Lucid Space Telescope, Lucid, EUCLID, Lucid Space Telescope, and the Vera Rubin Observatory in Chile. Lucid, which launched in 2023 and released its first batch of data early this year, will image monumental 1/3 of the entire sky with a clarity that only comes from being in space. Conversely, the Vera Rubin Observatory will be working from the ground, but will image the entire southern hemisphere sky. it will create the most detailed time-lapsed view of the cosmos ever seen. Over their lifetimes, Lucid and the Vera Rubin Observatory are predicted to unveil 100,000 new 100,000 new gravitational lenses, 100 times more than we currently know. And this image here is rather spectacular, and I think I've got that. I made sure that I got it. And there it is. Take a look at that. In the image you're on the screen right now, one of the first images released by the James Webb Space Telescope, this cluster, which is called which is called SMACS J0723.3-7327 is lensing many distant galaxies behind it. And every extended line that you see in that image there, every arc of light, every galaxy that's slightly elongated is a gravitational lens, or is a distant galaxy being gravitationally lensed at some point. The article continues on to say, how do we find these 100,000 gravitational lenses among the billions of galaxies observed by these telescopes? It is not feasible for scientists to wade through that many images alone. Instead, Lucid is relying on citizen scientists to help train AI models to know what to look for. By having people each look through a few images and classifying whether they are gravitational lenses or not, AI models can learn from these examples and can then search the entire data set. If you want to get involved, check out their website. From individual lenses providing unique new insights into distant galaxies to studying the effect over large statistical samples to understand the very nature of the universe, gravitational lenses do it all. They are the Swiss Army knife in an astronomer's toolkit, and we're about to be spoilt for choice. So there it is. That is an amazing image. Really is an amazing image, and I think if Einstein was alive to see it, well, he'd be gobsmacked. Yeah, it's pretty amazing stuff. And just a few weeks ago, I had an article and a picture of an amateur astronomer who actually managed to image with his own homemade telescope or home observatory the effect of a gravitational lens. So where we think that these images can only be really gained using specialized professional telescopes, it can be done with amateur telescope setups as well. Maybe not as not an image like that perhaps, but it can be done, and it is out there. It is there to be seen. Really quite amazing stuff. You're tuned to ASV Radio VK3EKH, the official station of the Astronomical Society of Victoria. And if you're interested in what the ASV does, just visit the website www.asv.org.au to explore the various aspects to the society. And then there's about 20 sections that make up the ASV. And if any of those sections when you read it, sound of interest to you, astrophotography, the club section, comet and meteor section, computing section, cosmology and astrophysics section, deep sky section, historical section, instrument making section, juniors section, lunar and planetary section, new astronomers group, radio astronomy section, solar astronomy section, and space exploration. That's all the very active groups there are. There's also I don't think it's there that I read out, but there is also a group that deals with light pollution as well. But just go to the ASV website, look under the sections tab, and each section there has its own self-explanatory page that you can open up and read. And if any of those sound of interest to you, you'd like to get involved with, get in contact with the section director. That was a bit of midway advertising. I've never done that before. All right, it's now 12 minutes to the hour. What's the next thing I was going to bring up? What was that? Oh yeah, I just talked about that. Okay, all right, I think I've got this picture here. Did I get his picture? Can't see it. Maybe I didn't. Okay, let me just, hang on a sec. Bear with me for a second while I see if I did. It's an old black and white photograph, and I just want to see if I caught it. No, I didn't. Just didn't have the time. I'll just save this picture now. It should be a JPEG. No, it's a PNG. I think that'll work. And just save that. And I should be able to bring this image across to vMix. Image, browse, bear with me. There it is, open, and you can see what I'm dealing with in just a few seconds. That was the picture I was trying to get. And who is this, you may ask? On the 9th of October 1873, 9th of October 1873, today in the history of astronomy, yesterday at least, the man who lays the foundation for our understanding of black holes is born. His name, Carl Schwarzschild. Carl Schwarzschild. I think I'm pronouncing that right. Carl Schwarzschild was born October 9, 1873, just one day after his famous collaborator Einar Hertzsprung, EJNAR, weird name, and grew up in a Jewish family in Germany. Schwarzschild was considered a child prodigy, publishing a paper on celestial mechanics by the age of 16. There it is. How many teenagers at the age of 16 are publishing a paper on celestial mechanics these days? I dare say none. He studied astronomy at the University of Strasbourg, and then went on to receive his doctorate from the University of Munich in 1896. After working at the Kufner Observatory from 1896 to 1899, Schwarzschild became director of the Grotzen Observatory and then the Potsdam Observatory, where he recruited and collaborated with Hertzsprung. While serving with the World War I German Army from 1914 to 1916, Schwarzschild offered the first solution to Albert Einstein's equations of general relativity. His development of the Schwarzschild radius, part of that solution, laid the foundation for our understanding of black holes. Unfortunately, while at the Russian front, Schwarzschild began to suffer from a rare autoimmune disease, and he was invalided home to Potsdam, and he died of something called Hemingus. Yeah, only 2 months later at the age of 42. I was actually going to look that up. Hemingus. I think I had that right. Hang on a second. Let me just grab a copy and paste of that. I'll see what that is very quickly. Right. A rare autoimmune skin disorder. It's a skin disorder. Hemingus is a group of rare autoimmune skin disorders that causes blisters and sores on the skin, mucous membranes such as in the mouth or on the genitals. The most common type is Hemingus vulgaris, which primarily affects the mouth and can lead to severe complications if untreated. Sounds like nasty stuff, and I suspect back in the mid-1940s there wouldn't have been much around to try and treat that. So that would have been a nasty thing to have passed away from, which was, like I say, at age 42. A bright man, and would have had a very interesting future if that had not have happened. Blame it on the war. All right, there it is. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Where is my VMix? There we are. Now, we've got a few more minutes to go if we keep restricting ourselves to that. This will fill it up. Did I get a picture of this? I don't think I did. No, I didn't. It's not there. It's not really important, I don't think. No, I won't worry about it. Anyway, all right. What would a bucket full of deep space contain? Have you ever thought of that? A bucket. How big is the bucket, though, is the question. I guess it's a standard bucket. A bucket full of deep space could contain an assortment of things, from neutrinos to dust to virtual particles. One would think that this excellent question would be easy to answer. A bucket full of deep space would contain essentially nothing. And, well, there you are. Outer space is, after all, the closest approximation we have to a vacuum. However, the universe is far more complex. So let's venture deep into the Orion Cygnus arm of the Milky Way galaxy where our Sun resides, with an average-sized 3.5 gallon or 13.2 litre cubic metre bucket. We'll scoop up some deep space and see what it holds. First, we'll find about 4 million neutrinos. These nearly massless elementary particles travel close to the speed of light and originate from stellar cores, exploding stars, and other regions where nuclear reactions occur. Some were even produced just after the Big Bang. Neutrinos so pervade the universe that billions of them will pass harmlessly through your body in the time required to read this sentence. If we could see this neutrino profusion as little dots of light, we would blindingly illuminate our bucket. We will also find about 13,000 gas atoms, primarily hydrogen and helium, the two principal constituents of the universe. To put this number into perspective, a bucket of Earth's air at sea level would contain about 13 septillion gas molecules. Septillion. That's 13 to about to the power of 24, 22, 24 numbers, zeros. 13 septillion gas molecules. So 13,000 atoms is a paltry amount in comparison, and this density varies considerably. We would find even fewer atoms in the space between the spiral arms of our galaxy or in the vast chasms of the intergalactic space. Also within our bucket might be a dust particle or two. However, the probability is low, considering the density of dust particles in space is 0.000001 per cubic metre. In other words, if we gathered 77 buckets worth of deep space, we would expect to find only one dust particle out here in the Orion Cygnus arm. If we were to collect all the dust particles within a volume size of our planet, they would fill a space about the size of 3 sugar cubes. We will also find quite a few photons emitted from stars and distant galaxies passing through en route to other regions. The only reason we can see stars is because photons travel from them to our eyes. Deep space is awash in these light packets, darting about in all directions. If we could trap the photons like neutrinos above, they would be bustling about the interior of our bucket. Bustling. But what about deep space itself? Apart from the neutrinos, gas, dust, and photons passing through, one would think that such a void would be, well, devoid of anything. Not necessarily. A strange concept from the thrilling, weird science of quantum physics is the Heisenberg uncertainty principle, which states that one cannot precisely know both a particle's position and its momentum. Additionally, one cannot precisely know the energy contained in a volume of space at a specific instant in time. Consequently, the vacuum of space is never empty, but it is instead bristling with so-called virtual particles. And these virtual particles, which appear in pairs, snap in and out of existence as they merge and then instantaneously annihilate each other. They exist in such brief periods of time that they cannot be directly observed. No matter how closely we scrutinize our bucket, we won't see them, but these too exist in our bucket of empty space. So, a bucket full of deep space would contain an assortment of things, from neutrinos to dust to virtual particles. The density of our bucket's contents would vary depending on our location, and from our comparatively congested galactic spiral arm of the Milky Way to the remotest region of the horrendous supervoid. Just know that bucket of empty space won't ever truly be empty. Dear me. All right. Courtesy of Astronomical.com, that one, on the Ask Astro tab. Alrighty then, let's just finish off with space weather very quickly. We've got a picture of the sun here, and that's the current sunspot lineup on the disk of the sun. If we could look at the disk of the sun right now, it says here that the solar wind is currently at 363.7 kilometers a second at a density of 4.2 protons per cubic centimeter. There it is, space isn't empty. The sunspot number is 87. The radio sun is currently at 122 solar flux units. The Aurora Australis is currently looking like this over the South Pole, so there is a little bit of a glow happening, but not. I don't think anything would be really visible in our skies at the moment. Still, that particular glow is not doing too bad. What else is there? The coronal hole. There is a coronal hole happening too at the moment. I think I've got that picture here. There it is. Just bring that up. Okay. Space weather says that Death Valley Cosmic Ray Balloon Payload. Oh, that's before the solar wind thing. Death Valley Cosmic Ray Balloon Payload. Regular updates to the narrative on spaceweather.com may be intermittent or delayed today. Dr. Tony Phillips is in Death Valley National Park recovering a cosmic ray balloon payload that landed near Saline Peak. Okay, just thought I'd read that out. The picture on the screen is a stream of solar wind is approaching Earth. A hole has opened up in the sun's atmosphere, and it is venting a stream of solar wind directly toward Earth. NASA Solar Dynamics Observatory photographed the dark chasm on October 9. This is a coronal hole, a region of the sun's atmosphere where magnetic fields open up and allow the solar wind to escape. Coronal holes look dark because the glowing hot plasma normally contained there is missing. A stream of solar wind flowing from this coronal hole should reach Earth on October 12. Its arrival could spark G1 class geomagnetic storms. The odds of storming are increased by the Russell-McFerran effect, which links the magnetic fields of the Sun and the Earth during weeks around the equinoxes. Interesting. Okay, that's about all I can really glean from spaceweather.com. As of October 10, 2025, there were 2,349 potentially hazardous asteroids. And the KP index, incidentally, planetary K index, is 2.67 and will reach to 3.67 over the next 24 hours, which is considered quiet. Righto, Mr. Brash, I think that's about it. So where's my camera? Where is my camera? I've lost my camera. There it is. Okay, on that note, it is 4 past the hour. I shall conclude this week's ASV broadcast. I hope you enjoyed the various articles, mostly courtesy of theconversation.com. I'd recommend that you check out the Conversation website. There is quite a few interesting things there. I hope they never decide to go ahead with this huge reflectors in the sky reflecting sunlight. It's just a ridiculous thing to do, honestly. All right, we shall now open up 3541 kilohertz for any stations wishing to check in. This is the moment in time where my modem tends to fall over because I start intermittently transmitting. So for those watching Discord and YouTube channel, apologies in advance if the stream suddenly stops. I can if YouTube falls over, I won't reactivate it. But if Discord falls over, I think it starts once the internet connection is re-established. It starts automatically. So just bear with the stopped image; it'll come back. But hopefully it won't fall over. Let me just check my Discord, and I can see that Andrew VK3KIS is there, and Steve VK3SBX is also there. It's a bit quiet there on the home front, isn't it? Yes, and I didn't mention about email, but someone might have remembered. VK3EKH@gmail.com, VK3EKH@gmail.com for any emails, and I can see that yes, Andrew is there listening on 80 meters, and who's that? Oh, g'day Dave, VK3AIF. He's there as well, loud and clear on YouTube feed. Good. Well, hopefully the YouTube feed won't fall over. So, highly recommend Discord. Anyway, all right. Thanks for those emails that have come through. Let me go now to 80 meters and see if I can find any stations that are prepared to say hi as soon as I get my pen to work. Is it working? Yep. All right. This is VK3EKH listing 3541. All right. Take off the headphones. VK3 Delta X-Ray, VK3 SBX. Is there anybody else?
VK3 TJS.
G'day, Jack. Anybody else? All right. VK3 Delta X-Ray. Go ahead, Greg. VK3 EKH. Good evening.
Five 9 plus 20. getting there and up there in the sky. And okay on the bucket of stuff. Interesting, very interesting. Right, Clint, back here. Thanks for running the show, mate. VK3EKH, VK3 Delta X-ray, Greg Inaudible.
Good on you, Greg. VK3 Delta X-ray, VK3 EKH. Not a problem, dear sir. You're 30 over 9 here tonight, so mightily strong signal coming into Narre Warren South. Not a problem at all. And I like I said, I was in the last 15 minutes before going to air scraping articles together, and I saw the bucket one, and I thought, oh yeah, that's about 5 minutes worth. So I thought that could be interesting. A bucket's worth of nothingness. Septillion. I had to look up this number that they referenced, 1.3, and it had about 23 zeros. And in the article, and I wasn't about to go 1.300.000.000. I wasn't going to do that. But I copied and pasted the whole number into Google, and I said, "What's another way of referring to this number?" And it comes up with septillion is another term that can be used. Where is it here? Septillion. I think that's how it's pronounced. Septillion. 1,000 raised to the 8th power, or 1,000,000 raised to the 7th power, or something like that. I don't know. Septillion. Never heard it before. But there it is. All right. No worries, Greg. Good on you, mate. Thanks very much. Good to hear you. Next on the list is Steve, VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. G'day, Clint. Yes, interesting stuff tonight. That reflects all. Honestly, I haven't heard of such a ridiculously irresponsible idea in donkey's ages. I just couldn't believe that. I wonder if this guy's heard of global warming too. Bad enough. We've got various people talking about putting things in space to shade us from the sun, and this lunatic wants to send the sun right back down. But it's just goes back. I noticed Bill and Donald had a bit of a thing on it too, and I was just looking at that while listening to you, and he seemed to think that it's apart from being an offensive idea, that it's just got a whole lot of views because it's such outlandish idea, and he gives it virtually no chance to succeed, and I hope he's right. Anyway, yeah, that's just mind-boggling, isn't it? Trust the Russians to have a go, though. I mean, they're in the same category, really.
Yes.
The gravitational lensing photograph is amazing, isn't it? That really is amazing. Yeah, I'm not sure if you said that it should, amateur telescopes should also be able to see gravitational lensing, at least to some degree. I was a bit surprised about that. I would have thought that those sort of objects were far too faint, but I don't know, that'd be interesting, wouldn't it? Anyway, there you go. All right, thanks very much, Clint. And next week, I'm not sure if I'm going to be here next week. We'll just have to see how we go. I've got one thing on next week, but it probably doesn't go. It probably finishes before you even start, actually. Okay, all right, thanks very much, Clint. And I guess you're going to let us know how you're getting on with your own rig. Thanks for CKCEKH,
My own rig. I love that. A term that you astronomer blokes use for your telescopes, the rig. I don't know. I'll have to come to accept that at some stage, I suppose. I've seen some really juicy rigs that people have got set up, and the first thing that my eye gravitates to, pardon the pun, the first thing that my eye gravitates to with most people's rigs is the amount of wiring that goes on. all the interconnection that's needed, USB cables and power cables, it really can make a rig look really messy, complicated. But on the other hand, it looks interesting. It looks like a scientific instrument, and it is. And some of the setups are just dumbfounding. And I'm on this road to getting this sort of thing happening. So I'm still coming to grips with how I'm going to interconnect things. I haven't begun to do it, but I know I'm getting there slowly but surely. Anyway, as an update, I'm after a dovetail for the Celestron. Now, I've spoken to Bill Stent out at Sidereal Trading, and he's ordering an appropriate dovetail for my Celestron, the 8-inch Celestron, because I'm going to defork it, and I'll mount that on the NEQ6 Pro equatorial mount, and that'll make using that telescope, I think, a whole lot easier. And it also means that I can attach cameras to the rear of that telescope fairly easily, because as you can imagine, in the fork design, there's not a whole lot of room between the bottom of the telescope and the bottom of the telescope, that part of the telescope that's bolted to the tripod. So I think I'll do that. I'll mount the Celestron to the NEQ6 and see how that basically works. So I've got that coming. It'll probably be a couple of weeks. There's something else too. Oh yeah, and I've also ordered a sensor, a cloud and rain sensor, a dedicated scope dome cloud and rain sensor, which will be mounted on the outside of the dome, and that will facilitate that if I'm doing any automated astrophotography at night time, and I happen to be going to bed and asleep, and I've left everything doing an automated arrangement. If the sky starts, you know what I'm talking about. If the sky starts to cloud up, the system will automatically close down. So if there's any chance of rain affecting or getting inside the dome, it'll just automatically start to shut down processes and protect everything, which is a cool idea. So yeah, I've got that coming as well. I'm just trying to quickly find this picture from an amateur that photographed the gravitational lensing. I'm pretty sure I've got it here somewhere, but it's going to take me a while to find it. So I'll dig it up for the future. I'm pretty sure you've seen it, because I remember mentioning that image, thinking that it was an amazing thing for an amateur setup to be able to photograph, and I'm pretty sure that you made the comment as well that that's pretty amazing that he was able to get it, but it is possible. I can't see it. I've got too many pictures here that I save, and it's going to take me ages to go through. So I'll dig it up. All right. Thanks, Steve. Who's next? It is Jack, VK3TJS in Shepparton. Go ahead, Jack. VK3EKH.
Yeah, VK3EKH and the group. This is VK3TJS. Good evening, Greg, Steve, and anyone else that might be listening. And certainly a good broadcast, and won't be late, but good transmission, no problem, and correct signal and stiff signals here, beautiful here in Shepparton. So it was good. Thanks very much for running it. Actually, the daylight saving helped me to be here, because it's only 10 o'clock, or after 10 o'clock on the whole time, so it's not that bad, because I've got to go to work tomorrow. We got show day in Shepparton for 2 days, today and tomorrow. It's a Shepparton show, so it's town's buzzing. We got activities and various other things that are happening around that time, so it's pretty good. Usually we've got rain around the show day, but looks like this year it should be good. Anyway, thanks Clint for running the broadcast. And just one question: is Discord running or not? Because I turned it on. There was nothing there, so I'm not sure whether that's still going on or not. VK3KH, VK3TJS, and the group.
Yeah, Roger Jack, VK3TJS, VK3EKH. Yes, as far as I can see, Discord is still running and YouTube is still running. They haven't fallen over. Before I took the call back, I did mention that usually it's this time when I start intermittently transmitting on 80 that the stream falls over, that RF gets into the modem and causes all sorts of problems. But from what I can see, YouTube is still running and Discord is still running. So Discord is still there, and I can see myself, and I can see the audio is working as well. So she's working okay, not a problem from what I can see. All right, okay, on the Shepparton show. Hopefully the weekend will be good for that. I think the weather is going to be acceptable. I can't recall what the forecast was for this weekend, but hopefully it'll be okay for that show up there. I understand that the Melbourne show was a great success. Not that I went to it. In fact, the last time and probably the only time that I've ever been to the Melbourne show was when colour television came out. They had a stage set up where they had the only colour television in all of Australia on display for thousands to see. And I remember a lot of people standing at the foot of this stage to get a glimpse of what a colour television looked like. And I was there. I was amongst that. And I thought, wow, look at that colour TV that was this small on the stage. So then a friend of mine, the late Dave Brain, VK3ADD, bought a Chrysler colour TV for his lounge room, and we could not believe it. This beautiful furniture piece and this great colour image. Oh, it was just fantastic to grow up watching black and white TV and knowing nothing else, and then seeing colour was just such a mind-blowing experience. Anyway, boy, hasn't it changed. Anyway, enough of that rubbish. All right, thanks, Jack. Yes, I've got to go and set my clocks. I've got about 4 clocks that need to be readjusted. I'm not against time daylight saving, although on one hand I'd be just as happy for it to stay on our standard normal time. But by the same token, I don't mind the way this change of hour brings in that extra daylight to play with in the evening. It works with me. So it's just a matter of getting used to it, I suppose. Anyway, is there any other stations wishing to check in? VK3 EKH listening. Lots of noise there. All right, cheers everyone. Take care. Have a lovely weekend and take care. And I've already said that. We'll see you all next Friday. Have a lovely week and take care and look after yourselves. This is VK3 Echo Kilo Hotel on behalf of the Astronomical Society of Victoria with the regular Friday night broadcast. We'll see you all next Friday. Cheers for now. Cheers, Steve.
Thanks a lot, guys. Catch you later.
Sorry, I had the mic going down. 1956, I wasn't around. I was born 1960. I think colour television, the colour television display was 1975, I think.
Roger, Clint. Oh, okay, I thought colour TV would come in 19... Oh, well, there you go, 65. Right, I'll go with your idea, Clint. Cheers, mate. Well done.
Yeah, I'm pretty sure it was around. We went all colour in 74, 75. I'm fairly sure that was the year. Yeah, I'm pretty sure of that. No worries.
Roger, Clint. Cheers, mate. Have a good weekend.
Cheers, mate.